Hi there, my name is Jonathan Cohn, and this is part 3 of my Xgrapher demo for the LabVIEW Example Contest 2010. In this video, I'll be showing part of the block diagram for the X control and how it works. I won't go into too much detail. I'd prefer if you dug through the examples yourself and tinkered with how the X control works. What I'll do is I will open up the Xgrapher. Now, if you take a look at my project file, this is the project that I used to build the Xgrapher demo at the start of this contest. And what I have here is my demo, which is what you've seen before in the previous 2 videos. Instructions is just a giant iPad that pops up with the instructions of how to use it. And the final thing is the actual Xgrapher X control. Now, if you were to implement this into your project, you would only need, you wouldn't need any of these in your project. If you just dragged the Xgrapher into your application, it would show up as a dependency. So you wouldn't ever have to handle anything else. It would be pretty much zipped up as a library. So, but what I have here, if you're not familiar with X controls, LabVIEW will automatically create 4 files for you right off the bat. And one of them is called init, facade, state, and data. And data is one of the more important ones because this is actually the data type that your X control will take as a terminal. So it's a waveform graph, so therefore it will show up as a 2-dimensional array of doubles. Originally, when I dropped in a waveform graph, it keeps it as a 1-dimensional array of doubles. So what I had done was drag this down to make 2 dimensions. The most important VI of these 4, though, is the facade, and the facade is actually what the main front panel of your application will display based on how the facade and the X control is built. So if we take a look at this, excluding the gray background because it's actually going to show up as transparent, this is how the X control is laid out, hence the facade. So this has a front panel and a block diagram associated with it. So what I did at first was I laid out the main waveform graph, I laid out the timeline graph on the bottom, and I laid out some other indicators that would show some data. I also put a splitter in between here so that this can be expanded up. But the main important thing is the actual block diagram. Let's see if we can grab it and bring it into this window over here. It's a little bit larger, but there we go. That'll fit. And LabVIEW will automatically create this event structure for you. You just basically fill in the blanks for it. What I'm doing here is just a bunch of event actions that occur because the user clicked on this area or dragged on this area or moused over on this area. So really what I have is just a bunch of events in my event structure that are handling what the operator does. Now remember that this X control is always running in the background even when the VI isn't running. So what that means is that this you have to be very careful with shift registers, references, and other things in your X control because there are only certain times when these shift registers get overwritten and written to. So for more on X controls, I'm not going to give you a whole tutorial on how X controls work, but if you're new to X controls, there's a good temperature conversion X control on NI's website. It also ships as an example in the example finder. It basically converts Celsius to Fahrenheit, Fahrenheit to Celsius, all in an X control. And that'll give you an idea of how things work. But I want to point out some of the main things that are going on here. And here's an example. Let's take, for instance, timeline cursor grab. Now, what this means is that basically the operator has moused over one of these cursors and clicked and is starting to drag it. And what I'm doing here is I'm actually changing the cursor color using the cursor reference to black. And that just basically allows the operator to know that they actually have a hold on that cursor. What I'm doing in this VI over here, this VI is pretty simple, but what it's doing is it's going through cursor 0 and cursor 1, which cursor 0 is the left cursor of the timeline, and cursor 1 is the right cursor, and I'm just getting the positions and I'm writing them to a cluster of left-right positions and also the span, which is the spacing in between those cursors. And I'll show you why I need that in a second. What I'm also doing, which is I thought this was pretty tricky. I couldn't figure out a way to do this, And after a bunch of different tries, if we go back to my main application here, let's load it up. If we go to, let me just relink this. If you take a look on the right and the left, this area over here is grayed out. And I did that because I wanted to show the operator that they're only looking at the white area of this graph. In other words, if you click and drag this guy in here, this is all grayed out. And so to do this, I went through a bunch of different variations. But what I ended up doing was there's a feature in waveform graphs, which we'll look at right here, which allows you to apply an image to the front, the middle, or the back of the waveform graph. And this would mean, like, let's say you wanted to apply a logo to your graph, like in the bottom right-hand corner. You can also draw images that way. You can draw circles, which is how I do the dot that moves around the graph. What I decided to do was draw a rectangular box of gray color, starting at this position over here and drawing it out over here. So in other words, in this area, there's a gray box. And over here in this area, there's another gray box. And I put it behind, since you can't make them half transparency, I put them behind the plots, but it makes it look like it's actually in front. And what happens is when the operator is doing a cursor move, I'm actually redrawing that rectangular box over and over again in the position that those cursors have moved to. Now, if the person programmatically turns off cursor redraw, which is that checkbox, I don't do that. I just basically do nothing. And originally I was worried that this was going to eat up graphical process time, but it turns out it actually works relatively smoothly. If you take a look at the main interface, I apply the changes. If I click and drag this, it's going to be hard to see on YouTube using the screen capture, but it follows that cursor along very, very cleanly, better than I expected. So it seemed like a pretty good way to do it, and it keeps processing power way down. You can also see when you move the mouse over the cursor, the color changes as well, and when you click, it also changes. So basically, I just kept adding features as I saw fit to the X control. For instance, mousing over. One of the other features, one of the first things that I implemented was the ability to change the cursor type as you move your mouse around. So LabVIEW automatically handles cursor change when you move over with mouse cursor change when you move over a graph cursor. It makes that little arrow icon, which I really liked, so I didn't want to get rid of that. But when you move to the center, I wanted to keep a hand tool, which in most applications means you're going to pan, you're going to click and drag. So really I like that for that section over there. And when you come back out to the main graph, well, I wanted the crosshairs, which is standard for LabVIEW in that area. So if I go back into the X control, into the facade, you can see that when you do a timeline mouse move, which is the standard, whenever you're moving the mouse, here's where I determine, this VI determines what area of the waveform graph of the timeline I'm actually in. So based on where the cursor is right now and where your mouse is right now, it'll spit out a enumerator, which basically is either you're on the left cursor, you're on the right cursor, or you're in the center, or you're not anywhere important. And then over here I decide that if you're at the left cursor or the right cursor, well then I want to set the mouse icon to 0, which means default, like let LabVIEW and Windows handle what the cursor changes, and therefore it would change into that left and right arrow. Now if you're on a default, well, don't do anything, and if you're on the move, well then change it to mouse cursor 11, which is actually the hand. And I thought that gave a pretty intuitive way of controlling the graph, and it seems to work. Now on the downside, once you leave the timeline area, which is controlled through a timeline mouse leave, I want to change the icon back to 0 because I didn't want the cursor to stay as a hand when the operator moves their mouse away from the X control. I want it to go back to a 0 so that LabVIEW will handle it. Otherwise, you'd mouse out of there and you'd go to like a numeric control and start typing, and your mouse would be a hand instead of an I-beam. So that gives you an idea of some of the hiccups that I had with this kind of stuff. You really have to take into account every single mouse move, mouse click, mouse drag that an operator can do, and make sure that it's flawless. Because in the end, if it does something crazy, you're not going to want to use it. So that's pretty much it. Now, in the very end, under a cursor move, during this VI right here, cursor update, this is actually the VI that will control the waveform graph, which is the main viewer graph. And really, all I'm doing is taking the left and right positions of the cursors, and I'm just adjusting the X scale range of the main waveform viewer, and I'm just changing those. It's very, very simple to do that, and it seems like a reliable way to manipulate the top graph based on here. So if this drags over to the left, the X range will expand. I hope that maybe you would download this X control and play around with it, and hopefully we could start a discussion on improving it and adding more functions and features, and I'll probably come out with a new version based on what people's inputs are, and hopefully you guys enjoy it. And remember, if you do like it and the contest voting starts, don't forget to vote for me. Alright guys, take care.